Welcome back. In this section, we have got question 10 from the June paper 2023. The question reads as follows. In a photoelectric investigation, light of different frequencies was radiated on each of the two metals A and B. The graph of maximum kinetic energy of the ejected electrons from metal A and the frequency of the incident photons is shown below. Point X on the graph represents an unknown maximum kinetic energy. So we have got point X here. That is point X. With an unknown, that is an unknown maximum kinetic energy. So the first question is 10.1. Write down the numerical value of the gradient of the graph. Now we know this question is coming from the section on optical phenomena, which is commonly known as the photoelectric effect. It actually is one of the last questions that you find in paper 1, which is physical sciences. Now, to answer question 10.1, we have here, we have this graph here, which is showing the maximum kinetic energy, which is our dependent variable, and then on the x-axis we have got a frequency. So now write down the numerical value of the gradient of a graph. Now we know that the gradient of a graph, if I can just generalize as we know it in maths, our average gradient is defined as change in y over change in x, delta y over delta x. So now in this particular case, we will find that we have our delta y is our kinetic energy. So there's change in kinetic energy. So we can interpret it according to this graph as change in the kinetic energy over change in frequency. Change in frequency. Now when we look at this particular arrangement, which is E over F, I'm just explaining how you can figure out the numerical value of the gradient. So when you look at this particular arrangement here, this value here will be equal to H. Now where are we getting the H? We know that the energy of a photon E is equal to H, which is Planck's constant, times frequency. So if we were to convert this one, make H the subject of the formula, you will get our H being equal to E, which means the energy divided by frequency. So what we are saying here is that the gradient of the graph is actually representing the value of H. Therefore, to write the answer, you just have to write down the answer. I'm just explaining here. So the numerical value of the gradient of the graph is H. In this case, our H will be equal to, we can just say H is equal to 6,63 times 10 to the power negative 34. So that's the value of H. Now this is a constant that we are given in the physical constants table here. So you'll find there is a Planck's constant, we call it Planck's constant, H, Planck's constant, H is equal to 6,63 times 10 to the power negative 3 joules second. So that's what we have here. So we write our answer as that. Now let's come to the next question. 10.2, define the work function. Work function is defined as the minimum energy required for an electron to be removed from the surface of a metal. So in other words, we are saying that there is a certain minimum energy of a photon that is needed for an electron to be emitted or to be ejected from the surface of a metal. That is what we call the work function. Calculate the work function of metal A. Now the work function is calculated as W naught, that is the symbol for work function, is equal to H times the cutoff frequency or the threshold frequency. So that is the formula, or we can write it as W naught is equal to HC over cutoff wavelength. So here we have to use the first equation. Again, these constants, they are given in the formula sheet. Over here we see that the work function is given over here. Work function is equal to H times F naught. Okay, or we can also use a cutoff wavelength. Now then we can then extract our cutoff wavelength here, our cutoff frequency. Now our cutoff frequency is this particular F. It is that F there, which means it is a 5 times 10 to the power 14 hertz. Now how do I know that this is a cutoff frequency? Now the cutoff frequency is where our maximum kinetic energy is a 0. So on this x-axis, our work function is a 0. Okay, so if our work function is a 0 on the line y is equal to 0, so that particular frequency over here is representing the cutoff frequency. So we can say that our cutoff frequency W naught is equal to H, Planck's constant, we have got that already, 6,63 times 5 multiplied by 10 to the power 34. Sorry, we need to work out, it's 6,63 times 10 to the power negative 34, which is our Planck's constant, multiplied by the frequency, which is 5 by 10, remember the units here, 10 to the power 14 hertz. And that will give us the final answer to that. So we have 6.63 to the power negative 34 by 514. We'll get 3.315 by 10 to the power negative 19. 3.315 by 10 to the power negative 19, that is joules. So that is our work function. And then the question goes on to calculate the value of x on the graph. So we have to calculate the value of x on the graph. Now as we can see here, x is representing the maximum kinetic energy. So we are saying that if our frequency is 12.54 times 10 to the power 14, what will be our EK max? That is the maximum kinetic energy. So we use the photoelectric equation here, 10.3.2, which is E, the energy of a photon is equal to work function plus EK max. Now our EK max is the x that we have here. So if I were to make EK the subject, I will get E minus work function, I will get my EK max, which is x. So basically we are saying therefore our x is equal to energy of a photon. The energy of a photon, the formula is HF minus the work function that we have just calculated here, which is 3.315 by 10 to the power negative 19. Now we need to substitute the values of h and f. So our h here, our h is again Planck's constant, which is 6,63 by 10 to the power negative 34 multiplied by the frequency. Now is the frequency of the light, which is given here, corresponding to that EK max, which is 12.54. So multiply by 12.54 times 10 to the power 14 minus this work function here, 3.315 by 10 to the power negative 19. And then we input those values in the calculator. Let's do that. So I'm going to take 6.63 I'm getting here 4.999 times 10 to the power negative 19. So which is basically 5 times 10 to the power negative 19. So just write 5 times 10 to the power negative 19 joules. So that is the value of the EK max over here. Now, how will each of the following be affected if light of frequency 12.54 times 10 to the power 4 Hertz, but of higher frequency is used? Choose increases, decreases, or remain the same. There's no effect. Now, what happens here is the fact that 10.4.1, now intensity refers to the brightness. So we are saying that when we use light of this particular frequency, the frequency did not change, but we increase the brightness of the light. So what would happen to the value of the maximum kinetic energy? Is it going to increase, or is it going to decrease, or is going to have no effect? Now, what we need to know is that the intensity of light can only change the number of photoelectrons that are removed. So it affects the number of photoelectrons removed or emitted. Why? Because the brighter the light, which means there will be more photons that are emitted in that particular light. So remember, each photon will transfer its energy, all of its energy, to one electron. So the greater the number of photons, and therefore we'll end up having more electrons that are being emitted. So in this case, the maximum kinetic energy will not be changed. The energy of a photon will not be changed. Remember the formula for energy of a photon. If I can just explain that one. Now, the energy of a photon, E, is equal to HF. So this can only be changed when the frequency of the light changes. So in this case, the frequency of the light did not change. So if we analyze the equation E, the photoelectric equation is equal to work function plus EK max. So the energy of a photon is not going to change because the frequency remains the same. The work function does not change because this is a material specific. It is specific to that type of metal. So the work function of a metal does not change, it's a constant. So if the E did not change and the work function did not change, so the EK max would not change. So in this case, we are saying that if we use light of a particular intensity, when we change the intensity of light, the value of X would not change. So to answer 10.4.1, we would say no effect. So 10.4.1, our answer will be no effect. Simply because its frequency that remained constant. We didn't change any, we used the same frequency. So which means that all the energies will remain the same. However, when it comes to 10.4.2, the number of photoelectrons emitted per unit time. So 10.4. This is what I had just explained now. So remember, the brighter the light, the more photons we have. So we have more photons, and those photons, each photon would therefore impact on many different on one photon. So the greater the number of photo electrons, the greater the number of actually the greater the number of photons emitted, the greater the number of photoelectrons. So in this case, our photoelectrons will increase. Our answer will be increases. Then metal B has a larger work function than metal A. 10.5, redraw the graph in your answer book. Do not include values on the axis. Also label this graph as X. On the same axis, on the same set of axes, sketch the graph of metal B. Label this graph as B. So they are saying that we must draw another graph of metal B. Metal B, it has got a larger work function. So if it has got a larger work function, how would the graph look like? So we basically draw this as is, and then we just have to draw that for B. So if we just to draw here the x-axis, and we just put here the x-axis like that. So this is y there, and this is x. Now we know A has got this graph here. A is there. Sorry, just undo that. A is over here. So A is over here. And now B will have a higher function, so B should be somewhere there. B should be somewhere there. Now, one thing here that we need to take note is these two lines must be parallel when we draw them. Remember, they've got the same gradient, which is a constant, which is Planck's constant. So they must be parallel. The distance between them must be the same. So this is a 5, and this is metal A. And now this one, you must put it at a slightly higher frequency. Okay, at a slightly higher frequency. There are no values, so just label it as B. Okay, so this will be 0, and this is your EK max. EK max over here. And this is our frequency. in hertz. So that should give you the answer to that particular question. Okay, so that's all on this question, which is a 14 marks based on photoelectric effect. So we'll see you next time.